Good morning, everyone. We're going to be looking today at our last lesson before our test, which is lesson 7.5. We're going to be writing equations of quadratic functions from graphs, tables, and data. Okay, so we're going to be looking at a few things you've done before, like creating a table from a graph, making sure that we can put tables into Desmos. We've done that a lot. And Desmos will help us to determine what is our a, b, and c value so that we can write the quadratic function in standard form. And can we use that to predict outcomes of real-world data? So let's start with a basic equation or a basic graph, and can we get the equation from it? So in order to get the equation, we need a, b, and c. Okay, just like we talked about up here, this is the equation. We need a, b, and c in order to write the equation. So we have to first come up with a table of data from this graph. So get some nice pretty points. Okay. Starting from the left, I see a nice pretty point right here located at -7, 13. We've got another beautiful point right here at -5, 7. The vertex, which is nice also, we've got -3, 5. And then, of course, the symmetrical points on the other side at -1, 7, and then one more symmetrical point, which is up here at 1, 13. And we can see our y-intercept is a decimal. It's somewhere between 9 and 10. We don't know exactly where, but we will find it out soon. And a reminder that the c value in an equation is the y-intercept. Okay, in case you've forgotten, the c value is the y-intercept. And I don't currently know what it is, but once I get the equation, I should be able to determine that. So let's open up Desmos, and I highly recommend you pausing the video and opening it up with me so you can try this as well. So the beginning part of this you should already know how to do, creating a table in Desmos by hitting the plus sign, table, and typing in all of your data that you have written in your notes just now. Take a moment to type that in myself. Those 5 points. I've typed in my x's. Now I'm typing in my y's. All right. And I can zoom out or move it up a little bit so I can see it a little bit better. You can see all 5 points plotted on there. Now on the second line, we are going to type in our regression equation. So we're going to start with y1, just like we did with all of our other regression equations, linear and exponential. Tilde, which is the squiggly line that we see. A, x1, but remember, it's squared. So we hit Shift 6 to make it squared. That's what it should look like. See how it created a parabola? Now, arrow to the right, plus bx plus c. There's an error here. What's the error? All the x's and y's have to have a 1 after it. I made an error, and this is a very common error. So you'll get this little symbol here on the left telling you that there's an error. There we go. The x's have to have 1s, and the y's have to have 1s. Okay, so keep that in mind. Once you do it a few times, you'll get used to it. Now looking here, we can see that our a is 0.5, our b is 3, and our c is 9.5. Sometimes we're asked to use fractions, sometimes decimals. To me, I would probably put decimals for this one, but if you need to remember how to turn them into a fraction, just type in the value. So if I wanted to know what c was as a fraction, that 9.5, type in the letter c and hit the fraction button. Okay, but this time I am going to write my equation as decimals. So first I'm going to write down my a, b, and c. Okay, I'm going to write it over here. My a was 0.5, my b was 3, and my c was 9.5. So now I can write my equation. My equation is y equals, or you could say f of x equals, I'm going to use f of x. We see that a lot on the STAR test. F of x equals, the a value goes first, then x squared, and then the B value, so it's positive, so plus, and then an X. And then our C value is also positive, so we'll put a plus 9.5. If you need to, remember, go back to the top. You can see the equation here highlighted, and all you have to do is replace the A, B, and C with the values that you get in Desmos. I have a y equals here, but of course you could also see f of x, g of x, h of x, etc. All right. So what I'd like you to do is take a moment, pause the video, and try getting the A, B, and C for example 2. It is also a table of data, so you should be able to type it into Desmos and get the A, B, and C value. So take a moment to pause the video and type in your data. Hopefully you have had a moment to type in your data. If you haven't, now would be a good time to do it. Pause the video again so that you can type in that data. I'm going to scroll down here so I can actually see the data. You can like click and drag, or there's the zoom in or out features. Okay, I can see the points. They don't make a perfect, beautiful, pretty parabola with beautiful, pretty numbers. That happens that way. So you can see this is, remember, this is a person diving into the water and coming back up. Okay, so let's go ahead and type in our equation. Let's remember how to do it. Y1 and then the tilde symbol. A x1 squared plus bx1 plus c. Remember, every x and y should have a 1. Okay. And now we have our a, b, and c. You can see c is 0. And remember, c is the y-intercept, and we can see that it does, in fact, touch the y-axis at 0. So that makes a lot of sense. Okay. And you can see at about 11.962 seconds, that's when the diver reaches the surface and comes back up. Okay. This is where they dived into the water, and this is where they came back up from the water. So let's go ahead and write down our A and B and C values so that we can write our equation. Okay, write one here. I'm going to write my A and B and C. Maybe I should make more space. A equals, I'm going to go back to this real quick, 0.26. My B value was negative 3.11, and my C value was 0. So that means I don't actually need to put the C value. Okay, the C value is 0. You don't need to write it. So our equation then would be y equals 0.26. The A value goes first, and then x squared. And a minus this time, since the B value is negative, x. And then I don't have to put this. The plus 0, I don't need to. It's like adding nothing. So I'm not going to put that. There's my equation. Now, sometimes on the STAR test, you're asked to make predictions. Predict the diver's depth, what it would be after 16 seconds. So there is a very easy way to do that in Desmos. So let's open it up. Right here, we want to know basically what happens at 16 seconds. So if you're looking at your table, 16 seconds, all I'm really wanting to do is extend my table. What happens at 16 seconds? How deep is he going to be at 16 seconds? So in here, all we have to do is on a new line, we want to find out where our x is equal to 16. And you'll see a vertical line pop up here on the right at 16. So what does happen at 16? Let's follow that blue line to see where it intersects with our graph, our parabola. So at 16 seconds, that's the x. The y is 16.8. That's the depth. So I'm going to write that down. 16.8. And let's use our units, which is feet. Now, in this problem, does that even really make sense? It's a diver. He's diving into the water, and then eventually he reaches back up. All these negative numbers in our y column are him under the water, right? Well, this is saying he's 16.8 feet above the water. That's not what happens in diving, and y'all know it once you reach the surface. It's not like you keep going into the air. So this is not really a reasonable answer. It wouldn't make sense. There's no way at 16 seconds he's going to be 16.8 feet in the air, because you don't just keep going, okay? But we were able to predict what would happen. We could predict what happens at 11.6 seconds or 12 seconds, etc. There's a lot of predictions you can make as to where his depth is. All right, I'd like you to take a moment to try the star questions that are on the right side. There are 2 of them. Remember, these are data. You've got some data here that you can make predictions about, and then you've got a graph down here where you'll have to make your own table before putting it into Desmos. So give those both a try, pause the video, and then you can unpause it when you're ready to see if you got the correct answers. Hey everyone, so looking at this real world problem, the first star question, I can kind of see this is a parabola. It does tell us in the function, in the problem, that this is a quadratic function, so it either has a minimum or maximum. I can see that starting at 24.9, it gets bigger and bigger, and then it reaches 30.1 and it starts to decrease again. So to me, 30.1 is the maximum, and it's going to keep getting lower. So my answer, I want to know what happens when the speed is 65, should be smaller than 29.1 by using that logic. Okay, it's going up, it's coming back down. So the answers 31 and 40.2 don't make sense. So I marked them out as my first logical answer choice without doing any other information. And now I have my data typed in, and I've got my equation, although that doesn't really matter. The equation isn't as important, but we do need to have it to see the parabola. Now we want to find out when the speed is 65 miles per hour, what is the miles per gallon. So we are going to type in x equals 65 miles per hour, and we need to see where our vertical line intersects our parabola, and it is at 27.877, and that rounds up to 27.9, which is answer choice A. Technically it was 27.887, but it had rounded, make sure that was correct, 877, sorry, but it rounds up. So that was the actual value that would go right here, given our predicted data. Okay, so that's a prediction that you need to make. Let's look at that last one. I've already put my table in here. And once again, if you remember that the A, B, and C, that the C value is the y-intercept, our y-intercept is 8, that the first 2 have a y-intercept of 16. Okay, you may even want to write that in your notes to remember that the C value, which is the constant, the one without an x, that's your y-intercept. And we know our y-intercept is 8, so I've marked out answer choices F and G. Okay, so we just need to look at the other 2, and we need to get what is our A value. Is our A value -1/2 or is our A value -1? Hopefully you put in your data and that you can see that the correct answer was H. Okay, it was -1/2 or -0.5, hopefully when you put your data in the calculator. So guys, in your practice, you're going to have linear, exponential, and quadratic functions to practice this on. So keep in mind, it's going to be a practice of all the functions we've learned this year so that you can prepare yourself for the STAR test. Okay? Thanks for listening and have a great day.